Hello kiddos, how are you? Welcome to PW Gulf, and today we are going to revise a brand new chapter, Continuity and Differentiability. Yes, a very important chapter from the board's perspective and also from the entrance exam perspective because it holds a lot of weightage. In board examination, this chapter will hold a weightage of around 8 marks. Around 8 marks out of 80, just imagine. Calculus itself is of 40 marks, and in that 40 marks, 8 marks is alone for this chapter. Entire chapter, continuity, differentiability, as well as methods of differentiation along with rules and Lagrange's mean value theorem will be revised by me today. You will notice that throughout the session, I will be keeping it very crisp without wasting any time. I have done a lot of homework already so as to minimize the task during the lecture. During the session, I can simply summarize the topic without wasting any time in writing down about the given topic. So are you in, everybody? Get ready to summarize this wonderful topic of calculus, continuity, differentiability. Now, what is the origin? From where this thought of continuity came into picture? Right. So, the people were already studying calculus. People were already differentiating functions. Differentiation, geometrical meaning you all must be knowing. It is nothing but slope of tangent at a point. There is a curve and you just draw a tangent at any given point. Let's say this is your point C. At this point you draw a tangent and try to find the slope of that tangent. It is nothing but derivative. Okay. So then the question was, in order to draw the slope, in order to draw the tangent, you must need a continuous, smooth, breakless graph, isn't it? If the graph has break in it, how can you draw the tangent at this point? I mean, there is a break in the graph. You cannot draw the tangent. So there was a requirement of continuous graph. That's how continuity came into picture. In order to differentiate the functions, it was needed that functions are continuous. Then we started exploring about what is continuity, what is discontinuity, when is a function continuous, when it is discontinuous, and so on and so forth. Okay. In simple words, if you are able to draw the graph without lifting the pen, it is called as a continuous function. If you are not lifting the pen, it's continuous function in layman terms, right? Now here are 3 graphs in front of you. Through these 3 graphs, we will try to understand which graph is continuous and which is not. Now, at first, when you observe the first graph, you all can understand, ma'am, the graphs, there is a break in between, discontinuous. Okay, I take your point. Second graph, there is a hole in between, a small gap, discontinuous. Okay. What about the third graph? Continuous? Bingo, you all are correct. So, just by looking, you could all understand whether it's continuous or discontinuous. Let's get into a definition of this slightly. Let's get into the definition of this. So, continuity is very much the formula and definition are same. When the limiting value is equal to value of function at that point, it is called continuous function. When the limiting value of a function is equal to value of the function at that point. Suppose we are calculating continuity at a point C. So when the limiting value is equal to value at that point C, it is called as continuous function. The definition is same as formula. Now, many a times, the function will change its definition. That means the function will have different values in left and right. And the same formula can be broken down like this. When LHL is equal to RHL is equal to f of c. That is, when limit x tends to c minus f of x is equal to limit x tends to c plus f of x is equal to f of c. When such a relation exists, any of the two, there are 2 formulas. Now your question will be, ma'am, which formula to use when? when to use the first formula and when to use the second formula. So I'll tell you in the questions when to use first, when to use second. But these two formulas are essentially one and the same thing. When LHL is equal to RHL is equal to value of function at that point, we will say that the function is continuous. We will say the function is continuous. So let's go back to this diagram and try to understand the theory. At point C, observe the left hand and right hand limit. Left hand limit is coming here. Can you see this green color? Maybe if not, I can take a darker shade. I don't know, this blue will be visible. Yeah. Can you see the left hand limit? Like this. Right hand limit here. Left and right are not matching. And this dot is nothing but f of a. So can I say here for this particular function, LHL is not equal to RHL. For the first one, left hand is not equal to right hand. That can also be written as limit does not exist. In class 11th, you have studied when LHL, RHL doesn't meet, it's called limit does not exist. In the second diagram, left hand coming at this point, right hand also coming at this point, but value of function at that point is somewhere up. So even though your left hand and right hand are equal, it is not equal to value of function at that point. See, this is. It is not equal to f of c. This is your f of c. Discontinuous. Here also discontinuous. And what about the third graph? Ma'am, in third graph, we can see that everything properly matches. Your left hand, right hand, and at that point. All three at one place coinciding. LHL is equal to RHL is equal to f of c. It is called as continuous function. Can you understand? That's the theory. That's the theory of the continuity at a point. What about continuity in an interval? We will go to that. Let's learn a topic, try a question, and then move. So here is a question. F of x is sine of 2x minus 1. Talk about its continuity at the point 0 and pi. When x is 0, when x is pi. Is it continuous, discontinuous, what? Different options. So firstly, it's a linear function. When I check at x is equal to 0, which formula will I use? Ma'am, I'm going to use the first formula, not the second formula. Second formula will be used when your question is, let's say, given in the form f of x is sine 2x minus 1 when x is greater than equal to 0 and f of x is sine 2x plus 1 when x is less than 0. When the function has different value in different areas, when the function has different value for x greater than 0, different value for x less than 0, then in that case you will calculate LHL separate, RHL separate. But if your function has only one value, sine 2x minus 1, and they have not mentioned anything, that means function has only one value throughout, everywhere, you will use the first formula. Same in this question, I am going to use the first formula. Let's try to find the limiting value. Limit x tends to 0, f of 0 and f of 0. Okay, limiting value and value at that point. Limiting value, value at that point. Limiting value, value at that point. When they both are equal, function is continuous. So let's get the limiting value. Limit x tends to 0. Sine of 2x minus 1 will be, put x as 0. You all know how to simplify limits, class 11. Sine 0, 0, 0 minus 1, minus 1. And if you are finding sine of 0 minus 1, again minus 1. You all can see limit x tends to 0, f of x is equal to f of 0. Limiting value is equal to value at that point. Therefore, function is continuous at x is equal to 0. And with the same logic, you will check for x is equal to pi. And the answer that you should get is the given function is continuous at both 0 as well as pi. Got it? Perfect. See, the basics of continuity is you should know limits. Class 11th limits, know it thoroughly, then you can do continuity. And that is the only reason, before starting this chapter, I have already made a video on the chapter limit of a function, in which all the questions are only on limits. Although it's done in class 11th, I did a separate video for class 12th, limit of a function. So this chapter becomes very easy for you. Talking about continuity in an interval, whenever they have mentioned an interval, they say find the point of discontinuity. If the question is find the point of discontinuity from 0 to 2, they have mentioned the interval. How will you solve such questions? So firstly, these 3 points, note it. It can come in some assertion, reason, question, case study, MCQ. You don't know. Because nowadays they want to check your analytical skills also. So just ratifying, solving the questions are not enough. You should know the theory also. Theory has now become important for boards also. Earlier it was not that important, but now it is. So when you talk about continuity in an interval, you must find that it is continuous in an open interval. When you are talking about continuity in closed interval A to B, first ensure that it is continuous at every point in the open interval within A and B. Right? At every point within A and B it should be continuous. Then at the point A, it should be right continuous. It should be right continuous. That is, the right hand limit and the value at f of A should be equal. Similarly, at B, it should be left continuous. The left hand limit at B and value of function at B should be equal. If you ensure this, the function can be declared continuous in the entire interval, closed interval A to B. Noted, hopefully. Next, also to solve questions, these points will help a lot. What are the points? In general, all 8 functions which I have mentioned are continuous. Constant function, modulus function, exponential function, rational function, polynomial function. Rational function is your f by g. Ensure that denominator is not 0. Of course, it's known to us. Then logarithmic, modulus, these functions are always continuous. Modulus, you know, V-shaped curve, always continuous. Trigonometric functions, now they are continuous in their domains. I am talking about their domains only. I am not saying that tan x is continuous everywhere. Tan x is continuous in its domain. What is the domain of tan x? It is all real numbers except odd multiples of 90. So tan x is continuous for all real numbers except odd multiples. Similarly, sin x, cos x, tan x, they will be continuous within their domain. And also inverse trigonometric function. Let's say, for example, sin x. Sin x will be continuous in the domain, sin inverse. We are talking about inverse trigonometric. So sin inverse will be continuous within its domain. What is then domain? -1 to 1 only. Outside -1 and outside 1, it will not be continuous because function is not defined. So all these functions in general are continuous within their domains. Let's talk about the algebra of continuity, that is when two functions which are continuous, f and g are two functions which are continuous. When they are added, subtracted, multiplied, divided, what happens? When you add two continuous functions, you get a continuous function. When you subtract, you get a continuous function. When you multiply two continuous functions, you will get a continuous function. And when you divide a continuous function, you will get the result also continuous. Ensure that denominator is not 0. My God, you all know why, right? And the last point, guys, when two functions are continuous, its composite is also continuous. What is composite function? F of g, g of f, f of f, g of g, right? These are all your composite functions. Studied in class 11? Right. So if f and g are continuous, the composites will also be continuous. If f and g are discontinuous at say any point, its composite will also be discontinuous at that point. So continuity, discontinuity. Dun, 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 dun. For this question, now this is also one type of question that can come. One type, one type of question is find whether it is continuous or not. Second type of question, they will say already it is continuous at x equal to 0. Find k. So you have to find an unknown value. That's second type of question. Third type of question is find the point of discontinuity. Three types of questions we encounter. Alright, now because the function is already continuous, I can use the definition of continuity. Which definition, first or second? So see, f of x is 3 sine pi x upon phi x when x is not equal to 0. And f of x is 2k when x is equal to 0. So at 0, the value of function is 2k. Rest everywhere, it is 3 sine pi x upon phi x, 3 sine pi x upon phi x. So everywhere it is same, only at that point it is different. First definition, not the second one. Second one is when left side is something else, right side is something else. In that case, you go for the second one. Here we will say it's first, according to first definition, limit x tends to 0, f of x is equal to f of 0. Why? What is the reason? Given function is continuous. Because the function is continuous, we can say this. Therefore, limit x tends to 0. What is f of x? 3 sine pi x upon phi x is equal to f of 0 is 2k. Simplify the left hand limit. Yup, 3 and 5 constants come out. Limit is all about adjustments, isn't it? सीमा कौन है? सीमा क्या करती है? Isn't it? Multiply and divide by pi, not phi, baba. Pi. Who did this phi? पकड़ो उसको. Pi. Multiply and divide by pi. Why? So that this becomes a nice, beautiful limit formula whose value is 1. Same. This is 1. And we have 3 pi by phi equal to 2k. From here 2 comes here, k is equal to 3 pi by 10. Option number B. Option B is correct answer to this. Proceeding guys. Now what can be the reasons of discontinuity? Think. Do not look at the screen, just think. When can a graph be discontinuous? When the left hand, right hand are equal, but the value at that point is not there, not equal. One reason. Or when the left and right are not equal, left going here, right going there, somewhere else. So left and right are not equal, limit does not exist. That can be a reason of discontinuity. And the third reason for discontinuity is when the function, value of function at that point does not exist. That means your left and right must be matching. This is point C. Left and right are coming properly at a point. But at C, the value of function, it does not exist. It is nowhere. F of C is not there. Does not exist at all. Not defined. Is not defined. These are the three reasons of discontinuity. This again can be your MCQ. Note this theoretical points. Let's talk about the types of discontinuity. Very important topic. Okay, not there in NCERT but in entrance examinations. Removable and irremovable are the two types of discontinuity. Again in removable, missed point and isolated. And in irremovable, finite, infinite and oscillatory. Removable discontinuity itself says that such discontinuities are very nice, easy, simple. You can do little manipulation and make the function continuous. It is right now discontinuous, but with slight modification you can make it continuous. That's removable. But irremovable discontinuity are very strong and you cannot make that function continuous. You can try, but you will not be able to make that function continuous again. It's discontinuous, it will remain discontinuous. So removable discontinuity, what is this missed point discontinuity? The point that I just now spoke of. When the LHL is equal to RHL but f of a is not defined. Like nicely, your left and right hand graph are coming in meeting, but the point is not defined. So how can you make it continuous? You define that point. If f of a is not defined, a is suppose the point at which you are checking. If f of a is not defined, you define. Let's say LHL is 3, RHL is 3. So you say f of a is also equal to 3. The discontinuity became continuous. You say f of a is also equal to 3. So that's how you remove the discontinuity. That's missed point. The point was missing. Second, isolated. When LHL, RHL are equal but not equal to f of a. That means when LHL nicely matches with RHL and f of a is somewhere over here. Can you see at A, the point is somewhere else, whereas LHL, RHL matches. So f of LHL is 3, RHL is 3, but f of a, let's say it is 4. The function is discontinuous. But you can make it continuous. Just bring this point back here. Just say that f of a is also equal to 3. LHL, RHL is already 3. You define now f of a as 3. That will make the function continuous. So missed and isolated. This was missed, point missing, isolated. Irremovable, finite, infinite, oscillatory. Finite means LHL not equal to RHL. LHL is going somewhere else, RHL is coming somewhere else. This is also called as your jump discontinuity. I mean, you cannot do anything. You cannot change the entire right hand limit. If it is a point, you can manage a point. You cannot change the entire function. So it's also called as jump discontinuity. Infinite means either your LHL or RHL is just going to infinity. And function, value of function at that point is also going to infinity. Infinite, you cannot do anything. And oscillatory, when the function lies between two values. I mean, your function is oscillating between two values. Not lies, oscillating between two values all the time. Then also such a function is irremovable discontinuity. Alright, great. Here is a question. At x equal to 3 by 2, the function mod of 2x minus 3 upon 2x minus 3 is what? Continuous, discontinuous, differentiable or non-zero? Okay, some students might think, ma'am, we can remove the mod and it will give me plus or minus, and then this will cancel. So f of x is equal to plus or minus 1, and so the function is continuous. No, this is absolutely wrong. When you put x equal to 3 by 2, the denominator will become 0. And that simply means it's a discontinuous function. It's a discontinuous function. This is after simplification you are getting plus minus 1. But for the function, it's not defined at 3 by 2. Let's move on to the next topic, which is differentiation. Continuity, I revised the theoretical part. Summary means mainly theory. Questions, we can do questions. Like for example, the next series that we come up here on YouTube is practice questions, PYQs. So in that, I'll just take questions. I will not talk about a single theory that time. And I will just say, go and watch the summary sessions for the theory. So only questions. Right now, it's the base building time. It's the start of the year, mid of the year. So we need to know these theories very well. Questions, few. Differentiation, it's the ability to differentiate. The ability to differentiate is differentiation. Now, differentiation simply means you all know it's calculating the slope of tangent at a point. At any point, if you calculate the slope of tangent, it's called differentiation. Now, in differentiation also, you have the left hand derivative and right hand derivative. If the left hand and right hand derivative come and match, you get a nice tangent. you will get a tangent, and that means it's differentiable. But if left hand tangent, right hand tangent doesn't meet, that means you cannot draw a tangent. How will you find the slope? If tangent cannot be drawn, slope cannot be found. It's not differentiable. So what are the reasons for not differentiable? One of the reasons is when the function is discontinuous. Let's say the function is discontinuous. There is a break in the function. How can you draw the tangent? You just can't draw the tangent. It's not differentiable. The second reason can be when the function has a sharp point. Even then it is not differentiable. Why? One reason is discontinuous, the other reason is sharp point. Why at sharp point it is not differentiable? Because you can draw multiple tangents. So the left and right hand tangents are not meeting. It's not a unique tangent which forms. One line is coming from there, the other line is coming from here. The left hand right hand derivative doesn't match. So at sharp points, functions are not differentiable, and that tells us modulus functions are not differentiable at vertex. You all must be knowing the graph of mod functions. Like if I draw the graph of mod x, the vertex is at x equal to 0. So at x equal to 0, it is not differentiable. At x equal to 0, it will be not differentiable. Suppose there is a graph of x, mod of x minus 2. So where is the vertex? It is at 2. At x equal to 2, the graph is not differentiable. It is continuous. It is continuous. You can draw without lifting the pen. But it is not differentiable. Why? Sharp point. Sharp point. So modulus functions are not differentiable at the vertex. At other points, like for example at x equal to 1, yes, it is differentiable. Left hand, right hand derivative will match. But at the vertex, not differentiable. Alright. So look at this formula then now. LHD equal to RHD. Limit h tends to 0 f of x minus f of x upon minus h is equal to f of x plus h minus f of x upon h. The only difference is here there is a minus sign, whereas you can notice a plus sign on the right hand derivative. This is nothing but your first principle of derivative, class 11th. And what's the reason for function not differentiable? When LHD is not equal to RHD, or when it has a sharp edge, sharp point, right? Let's check out a question on this. F of x is equal to x plus 1 when x is less than 2 and 2x minus 1 when x is greater than equal to 2. Then what is the value of f dash of 2? Okay. Now this question can be done within seconds if you have to do a multiple choice objective paper. But if it is a subjective paper, then yes, you have to show all these steps. I will do by both the methods. First of all, let's do by the shortcut way, because yes, f dash of x. Let's first differentiate by using the formulas. Derivative of x plus 1 will be 1 when x is less than 2. And derivative of 2x minus 1 will be 2 when x is greater than equal to 2. Guys, x less than 2 means 2 से छोटा LHD, 2 से बड़ा RHD. Putting x as 2. By putting x as 2, it actually doesn't change. So this is nothing but essentially your LHD and RHD. Whoa. LHD is not equal to RHD. I mean 1 and 2 are not equal. So in that case, f dash of 2 does not exist. It is not differentiable. The derivative doesn't exist. Shortcut done. Now let's do the long method, which is the actual method of solving. LHD, write down the formula. F dash of 2 minus is equal to limit h tends to f of 2 minus h minus f of 2 upon minus h. Alright, which is limit h tends to 0. What is f of 2 minus h? F of 2 minus h means in the left hand derivative function. This is your left function, right function, isn't it? Less than 2, greater. So in the left function, in place of x, you will put 2 minus h. In place of x in this function, 2 minus h plus 1. right? Minus f of 2. In this same function, my dear boys and girls, many of the students go here and substitute x as 2 because ma'am equal to sign is here, so we will substitute here. You can do that also, and if you substitute in the same function, it's still fine. Why? Because it's anyways continuous, so it doesn't matter. You substitute x as 2, 4 minus 1, 3, 2 plus 1, 3. So 3 over here. Upon denominator is minus h. 2 plus 1, 3, 3 cut. We have minus h upon minus h, and what is the left hand derivative coming out to be equal to 1. Alright, we also got 1 left hand derivative. Perfect. Let's go for right hand derivative. F dash of 2 plus bahar. That's limit h tends to 0. F of 2 plus h minus f of 2 upon plus h. Limit h tends to 0. In the right hand function, instead of x, you will put 2 plus h in the right hand function. So 2 times 2 plus h minus 1 minus f of 2 means in the same function put x as 2. And we just saw here 2 2s are 4 minus 1, 3 is what we are getting upon plus h. Simplify. Limit h tends to 0. 2 2s are 4 plus 2h. Minus 1 minus 3 is minus 4 upon h. Dun, 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 dun. 2h upon h will be equal to 2. That's what we also got. LHD is not equal to RHD. Therefore, f dash of x does not exist. If f dash of x does not exist, I mean f dash of 2 does not exist. We check that too. F dash of 2 does not. Question solved, long cut, shortcut. I hope you are able to get the crisp of the chapter. Perfect. So every differentiable function is continuous. What is the relation between differentiability and continuity? Every differentiable function is continuous. I mean, if you want to find the slope of tangent, it has to be continuous. If it is differentiable, isn't it a common sense it should be continuous? If you want to draw the tangent, it has to be continuous. There cannot be break. If you are studying A, B, C, D, and if you know D, that means you already know it, C exists. A, B, C, D. So if you are talking about D, that means C exists. If it is differentiable, C continuous already. Whereas vice versa is not true. Every continuous function may or may not be differentiable. Like for example, mod function. It is continuous, but it is not differentiable. Isn't it? Continuous, but not differentiable. So every continuous function may or may not be differentiable. Depends. Some continuous functions may be differentiable, like for example, sin x. It is continuous and it is differentiable, both. You can draw the tangent also at each point and find the slope. You can also see the continuity. There is no break. So some continuous functions may not be differentiable, may be differentiable. Depends. Alright, remember this. If you know D, you will know C also. If you know C, then there is ambiguity. You may know D, you may not know D. Depends. Here is a question. Function y is equal to e raised to minus mod x is what? Continuous, differentiable, neither continuous nor differentiable, etc. etc. That means you have to check both the continuity as well as differentiability for this function. Let's go one by one. For continuity, firstly, this function has a mod. Mod means split. Mod means split. Always mod function calls for a splitting. We will rewrite this function into two parts. E raised to, first remove the mod and put a minus sign. That gives e raised to plus x, and this is the case. We are putting a minus sign. That means when x is less than 0. And now remove the mod and put a plus sign when x is greater than or equal to 0. Can you see the functions now have two different values in two different sections. So in order to check the continuity, ma'am, we will use the first formula or second formula? Ma'am, we will use the second formula, because in the left of 0, the function is e raised to x. On the right of 0, it is e raised to minus x. Different values in different regions. LHL, RHL, separately you will find out. Okay, let's find the LHL. Limit x tends to 0 minus f of x, which is limit x tends to 0 minus which function? First or second? X less than 0, first function. Put x as 0, anything raised to 0 is 1. Great. What about RHL? Limit x tends to 0 plus f of x. E raised to, RHL is e raised to minus x. Put x as 0, anything raised to 0, 1. Great. Okay, we will also find f of 0 at 0. Here there is equal to 0. So e raised to minus 0 is same as 1. LHL is equal to RHL and is equal to f of 0. Therefore, function is continuous at x equal to 0. Continuity is verified, guys. Function is continuous. Okay, option A can be correct. B is out. C can also be correct. D is also out. So based on continuity, two options are out. Now we have to check about the differentiability also. Shortcut? Chalega? Let's do the shortcut here. F dash of x, find out. Derivative of e raised to x will be e raised to x. And that's your when x less than 0. Derivative of e raised to minus x will be e raised to minus x. By chain rule, derivative of minus x is minus 1 when x greater than equal to 0. You are checking for x equal to 0. So substitute. Anything raised to 0. This is 1 and this is minus 1. LHD is 1. RHD is minus 1. My dear bachos, LHD is not equal to RHD. Therefore, not differentiable at x equal to 0. Therefore, the answer is C. Answer is option C. Continuous but not differentiable. And we just now saw here mod functions are not differentiable. सोचा? किसने सोचा? बहुत अच्छा सोचा. अगर सोचा नहीं सोचा तो क्यों नहीं सोचा? और ये देखिए, मैंने बोला था, मैंने बहुत होमवर्क कर रखा है यार, बहुत काम कर रखा है. ये देखो, these are all your 11th standard formulas of derivative. I hope you all know this. Just have a glance through it. You can pause and have a glance. I'm going aside. Okay, once these formulas are known, you can also go through these formulas. The product rule, quotient rule, UV rule and U by V rule. U derivative of V plus V derivative of U. In quotient rule, first you will take derivative of denominator. V derivative of U minus U derivative of V upon denominator square. And for addition and subtraction, multiplication, division done. Addition, subtraction are easy. Just separate the terms. Derivative of constant is 0. These are the basics which you should know before you go on solving these many types of differentiation problems. Methods of differentiation. 7 methods of differentiation. Composite, implicit, inverse, exponential, logarithmic, parametric, double derivative. Let's go on one by one. First, I'll discuss in short the theory and then in the end to the questions. Okay, I'm not going topic, question. I mean, a lot of questions are mixed, mingled. It is implicit also, it's composite also, it's log, everything. So, we'll do the questions towards the end. Here, what is chain rule? Let's try to understand the chain rule first. We all know what is derivative of sin x. Yes, ma'am, derivative of sin x is cos x. Just now you showed here. Eh? Here, ma'am. Yeah. Pakka. Cos x. Right. What is derivative of sin of x square? Sin of x is known. Cos x. What about x now changes to x square? दिन बदल गए, just बात बदल गए. So derivative of sin of x square can be written as cos of x square, but my dear students, this is x square, something different. So chain rule says, why don't you multiply with derivative of x square? Why don't you multiply with derivative of x square? And that's 2x cos of x square. Understood? So x is replaced with something else. This x is replaced with x square, root x, x by 100. Let us call this as u. X is replaced with something else. Let us give a new term to it, u. It can be x square, x, root x, or anything which is not mentioned here. What will be derivative of sine root x? Ma'am, derivative of sine x is cos x. So derivative of sine root x will be cos root x. But by chain rule, you will multiply with derivative of root x, which is 1 upon 2 root x. Final answer is cos root x upon 2 root x. Similarly, derivative of sine x is cos x. Derivative of sine x by 100 will be cos x by 100. But by chain rule, multiply with derivative of x by 100. What is derivative of x by 100? X 1 by 100 constant, x derivative 1. So 1 by 100 into cos x by 100. Can you all understand that whenever we have something other than x, you are multiplying with its derivative? Simply written here. When you have something other than x, you have to multiply with its derivative. That is what chain rule is. In some questions, chain rules are applied multiple times. Now to simplify your question, composite functions, these functions which I wrote, these are nothing but your composite functions made by two different functions, sin x and x square, combined to make sin x square. So these are composite functions. When you want to differentiate composite functions, this table is going to be super duper helpful for all of you. And how? Divide every question that comes across you in these 5 categories. It will always fit into one of these 5 categories. Understand, listen carefully. If you listen, if you understand, you will thank me later and you will say that your chain rule is now forever cleared. You are never making mistake in the questions of derivative. Listen carefully. What is polynomial function? When you have variable raised to constant, like x raised to 3, x raised to 9, x raised to 500. Variable raised to constant, those are polynomial functions. Function derivative. But now instead of x, the x has turned into something else. Like there x turned into x by 100, x square, root x. Now x has turned into something else, let's call it u. So if you, instead of x, you have something else and then in the power of constant, derivative is same, n times u raised to n minus 1. But by chain rule, multiply with derivative of u. Whatever is this function, if it's not x, whatever it is, multiply by its derivative. Exponential functions is inverse of your, inverse not inverse, kind of converse of your polynomial function. Polynomial function has variable raised to base, here it's a variable raised to constant, here it is constant raised to variable. Like 3 raised to x, 100 raised to x, etc. Derivative is a raised to x log a. Instead of x, now you have u. A raised to u derivative will be a raised to u log u, a raised to u log a, and by chain rule multiply with derivative of u. Alrighties. That's second type of function. Polynomial, exponential. Exponent function, derivative of e raised to x is e raised to x. So derivative of e raised to u will be e raised to u. By chain rule, du by dx will be multiplied. Logarithmic, derivative of log x 1 by x. Derivative of log u 1 by u into du by dx. And some trigonometric functions. I have taken an example of sin x, but it can be any function, tan, cot, sec, cosec, whatever. Sin x derivative cos x, sin u derivative will be cos u into du by dx. Hope you all know this very simple technique to remember the formulas which is written here. All the c functions have minus sign, sorry. All the c functions will have minus sign. C. Can you see? C functions will have minus sign. Okay. See, so much of homework I have done. Next, implicit functions. Note down that table, it will be boss level helpful for you. Implicit functions. Now, what is an implicit function? Firstly, A function in which x and y are mingled together. Theory and all you can read. But implicit means x and y, y is not explicitly written in terms of x. Like y equal to, sorry, this was by mistake. This was supposed to be an explicit function. Let me rewrite it as y is equal to x square plus 3x cube. Can you see? Y is explicitly written in terms of x. Y on one side, everything else. Dependent variable is expressed in terms of independent. Y is dependent, x is independent. That's your explicit. But when they are mixed, dependent, independent, mixed, it's called implicit function. How to find the derivative? Very simple, yeah. Just differentiate both sides and take all the dy by dx terms on one side. That will take care of all the questions of implicit function. The only thing that you must remember very well in case of implicit question is derivative of y is y dash. Derivative of y square will be 2y into dy by dx. Chain rule, that's what we just now studied. If it's anything other than x, you have to take its derivative. So here instead x square derivative is 2x. So y square derivative is 2y. But this is not x now, this is y. So multiply with its derivative. What will be derivative of y cube? 3y square. But this is not x, this is y. So you have to multiply with derivative of y. That is exactly what your chain rule is. Remember this while solving questions of implicit. Next, inverse trigonometric functions. Now these are the kind of questions in which lot of simplification comes in picture. Like before you even solve the question, before you differentiate, try to simplify the question. And how to simplify? Using this table. This table will help you a lot. And this table comes in the chapter Continuity Differentiability. It will come in the next chapter, your integration also. It was there in previous chapter, inverse trigonometric function also, where I explained the logic, why x is a sine a cos, why this substitution is happening. This logic was also explained. Okay, so this table should be known to you and these formulas. Once again guys, can you see your C functions with minus sign? C functions are like change the sign, C for change. Alright, ITF functions, simplifications are the boss, and check the domains also towards the end, whatever is mentioned. Exponential and logarithmic are like direct differentiate, there is nothing separate about it, directly differentiate. Logarithmic derivatives, yes. So whenever you have a question now which doesn't fit into any of the 5 categories, I told you 5 categories, all the questions will fit in 5 categories: polynomial, exponential, exponent, trigonometric, logarithmic. Right? If your question doesn't fit in any of those categories, I mean it's something else only, it's x raised to x. This is neither polynomial nor exponential. It's variable raised to variable. If it's variable raised to constant, polynomial. Constant raised to variable, exponential. But it's none of them. It's function raised to function, variable raised to variable, function raised to function. And whenever such a question comes, there's a different way altogether to solve it. Not chain rule, but you will do logarithmic differentiation. You will do logarithmic differentiation. How? We will talk about the steps. So that's one. Whenever you have function raised to function, or you have addition, subtraction, multiplication, division, power, square roots of too many functions. Example like this. I mean, if I ask you to take the derivative of this, it will be so difficult, isn't it? Using log, it will be super duper simplified. Log properties one should know, like the product rule, quotient rule, exponential rule of log. That I hope you know. So what are the steps? Just take log on both sides, then differentiate both the sides, and then just keep dy by dx on one side, shift everything on the other side. Well, a very important type of question which comes in this logarithmic differentiation, and most of the students make mistake. When you have two function raised to functions added together. Now in this case, you will not follow this step like take derivative on both sides, take log on both sides. No, take log on both sides will go wrong here. Don't take log directly. What did I do? Yeah. Don't take log directly in such a question where two function raised to functions are added. You will separate them. Let the first part be u, second part be v. Solve the first part separately, second part separately, and then in the end you will add them. U and v you have to separate, take log, differentiate, find them separately and then add. Okay. Find du by dx, find dv by dx, and then this is u, v. Du by dx plus dv by dx will give you the answer. You have such questions in your textbook. Parametric function, whenever a question has a parameter, some third variable comes in picture. X and y you can see is expressed in terms of theta. So theta is the parameter, always differentiate with respect to theta, the parameter. And the formula is dy by dx is dy by d theta upon dx by d theta. If you are finding double derivative, d by d theta of dy by dx into d theta by dx. Note it down. You can also remember it. This d theta cancels, so you can see d2y numerator and dx square denominator. So this d theta is kind of balancing it. That's how the formula comes. Remember it. Double derivative when it is parametric. Double derivative when it is parametric function. And last guys, second order derivative. A function is there, y equal to f of x. If you differentiate once, f dash of x, y dash, y dot, y1, first derivative, y prime, d1, dy by dx. These are different ways of writing first derivative. And if you differentiate it again, y double dash, f double dash, I've written this twice. Okay, this is all written twice, sorry. d2, d2y by dx square, y double dot, y2, second derivative. These are different ways to write double derivative. So let's do some questions on all these methods of differentiation, and then in the end we will revise roles and mean value theorem. The derivative of log of mod x will be what? Guys, it goes very simple. They have not mentioned any range. So if you differentiate dy by dx 1 by x and x not equal to 0. Why? Because log of negative number doesn't exist. Log of minus 3 doesn't exist. So how can you take negative? It has to be positive only. The mod doesn't make sense. It's the definition. Answer was C to the previous question. I hope I marked yes. X is equal to e raised to y plus 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 e raised to y all the way till this is being repeated infinite times. What is dy by dx? Okay, e raised to y plus 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 e raised to y. I mean, this goes on. Can you all see that this is e raised to y plus this entire thing is going till infinity? E raised to y plus e raised to y. That is nothing but your question. This entire thing which is going till infinity, can I rewrite it as x? Because that's the question, x. Out of infinity, if you subtract 1, it doesn't matter. Infinity you actually cannot count. So it is still your x. And now the question has been reduced to this. It's very easy to differentiate. Directly, you want to direct differentiate or take log? Take log. Take log easier. Log x is equal to, if you take log of e raised to y plus x, and using the exponential property, y plus x will come here into log of e. Log of e is 1. I hope you all know log e is 1. Ready to be differentiated. Derivative of log x 1 by x, derivative of y dy by dx, and derivative of x 1. Rearrange it. We want dy by dx. 1 upon x minus 1. 1 minus x upon x, which is option B. B से बरोबर. Bindas. So this was a question on log. How to take log. Take log, differentiate, keep dy by dx on one side and get the answer. Isn't that exactly what we wrote in the steps? F of x is given, g of x is f of x, composite function. Then what is g dash of x? You have to find derivative of g dash of x. See, there are two ways to solve. First, you find what is f of x. Like you try to find the composite function f of f. In x, in the function, you will instead of x substitute f of x. And then solve it and get f of f, which is nothing but g of x. Once you will get your g of x, just differentiate it, you will get g dash of x, composite function. Other ways, using chain rule. If I have to differentiate this function, first I will differentiate the outer function, f dash of f of x into, and then the inner function, f dash of x. So f dash of f of x, what is derivative of f of x? Write down the derivative of f of x. No, derivative of, okay, f of f anyways we have to find. So f of f means, alright, instead of x you will put x upon 1 plus x divided by 1 plus, instead of x you will put x upon 1 plus x. Simplify, x upon 2x plus, I'll write down 1 plus x plus x. That's x upon 2x plus 1. And if you directly now try to take the derivative, why to do this? Just do u by v rule. V derivative of u minus u derivative of v upon v square. 2x plus 1, derivative of x is 1 minus x, derivative of 2x is 2 and derivative of 1 is 0 upon 2x plus 1 the whole square. 2x cancels, the answer is 1 upon 2x plus 1 the whole square, option D. Okay, good. Okay, find the value of this function at x equal to pi by 6. Y is tan inverse of root 1 minus sin x upon 1 plus sin x. Now, a very typical question from class 11th, the simplification is learnt by us. If not, don't worry. See how it is done. Y is equal to, as I said in inverse trigonometry, first lot of simplification and then later you differentiate. Differentiation is very easy in ITF. Mainly it's simplification, how smartly you are able to simplify. 1. Guys, can I write this 1 as cos square x by 2 plus sin square x by 2, the identity are? Yes or no? Cos square x by 2 plus sin square x by 2. Everyone, any problem? No problem, very good. And then sin x as 2 sin x by 2 into cos x by 2, because sin 2 theta is 2 sin theta cos theta. Here plus 2 sin x by 2 into cos x. The numerator, the denominator has formed a beautiful formula. A square plus b square minus 2ab. A square plus b square plus 2ab. That is a plus b the whole square, a minus b the whole square. The square and square root will cancel off. Ideally there is a mod, but they have mentioned x in first quadrant. So in first quadrant, tan inverse is positive. So we will cancel the square and square root and take only the positive sign. Great. Wow. This is equal to tan inverse of, now square root square gone, cos x by 2 plus sin x by 2 upon, numerator is minus by the way. How come I interchanged the sign? I always do that. Okay, here also numerator has to be minus. Check. Denominator is plus sin x by 2. Now, does it look something familiar to you? Yes, ma'am. Divide numerator and denominator with cos. Divide numerator and denominator with cos. 1 minus tan x by 2 upon 1 plus tan x by 2. This 1 can be written as tan pi by 4. Tan pi by 4 plus tan x by 2. And then denominator, this is 1 into tan x by 2, which can be written as tan pi by 4 into tan x by 2. Again, this turns out into a formula. What formula? Tan a plus tan b upon 1. Tan a minus tan b, ma'am. कब सुधरोगे ma'am? Tan a minus tan b upon 1 plus tan a tan b is a formula of tan, yeah, it is a formula of tan a minus b. A minus b, right? This is y. So far we have not differentiated, just simplified. Tan inverse tan cancel. Y is equal to pi by 4 minus x by 2. Now it's ready to be differentiated. Dy by dx. Derivative of pi by 4, 0. Derivative of minus x by 2 is minus 1 by 2. Option A is correct. Nice question. Option A is correct. This is simplification from class 11 trigonometry, nothing else. F of x is log of log x, then find the value of f dash of e. Chalo, differentiate guys. Chain rule. Now you will use your chain rule. It's logarithmic. It's fourth type. So instead of log x, you have log u. Derivative of log u is 1 upon u. This entire thing is u. And by chain rule, you will multiply with derivative of u. Can you understand? This entire thing is your u. Log u. Derivative of log u 1 by u into derivative of u. That's 1 upon log x into derivative of log x 1 by x. F dash of x, put x equal to e. 1 upon e times log e. 1 upon e is e raised to minus 1. Log e is 1. Answer option E. गुड डे जी, बल्ले बल्ले जी, मस्त है, एकदम तगड़ा है, बढ़िया है, बहुत अच्छा है. y is equal to cos cube x, ma'am. Composite function guys. First, polynomial. Variable raised to constant. Variable raised to constant. It is like, do not get confused. Cos cube x, cos x the whole cube. So when you take derivative, first derivative of power 3 times cos raised to 3 minus 1, and by chain rule multiply with derivative of cos. This is your chain rule, isn't it? X raised to n derivative is n x raised to n minus 1. So u raised to n derivative will be n u raised to n minus 1 into derivative of u. Instead of x you have cos x. Instead of x you have cos x. X cube derivative is 3x square. Cos x cube derivative will be cos x, the whole cube derivative will be 3 cos x the whole square, and then derivative of cos x, which is minus sin x. Oh. Okay. Fine. I just read the question halfway. Find derivative of cos cube x with respect to sin cube x. So this is called differentiation of one function with respect to other. You remember in parametric, I had written differentiation of one function with respect to other. Always in such cases, say one as u and the other as v. Call one as u, the other as v. And the question is, find du by dv, isn't it? Differentiation of u with respect to v. And from parametric form, we learn u is in terms of x, v is in terms of x, du by dx upon dv by dx. This is your parametric formula. I know it's not theta and all, normal thing, but yeah. dv by dx, guys, differentiate. It's like your same thing with sin x the whole cube. dv by dx. Derivative of x cube is 3x square. So derivative of sin x cube will be sin square x, and by chain rule derivative of sin x will be multiplied. That is equal to 3 sin square x, and derivative of sin x is cos x. Substitute the two values. Du by dx minus 3 cos square x into sin x upon 3 sin square x into cos x. 3 cancel, 1 of the cos, 1 of the sin cancel. Minus cos upon sin, that's minus cot, option E. So we tried covering questions on composite, inverse trigonometric, logarithmic, parametric, everything. One double derivative was left. Composite also we did, yeah. Implicit also. One double derivative was left. Let's do it. Y is given, what will be d2y by dx square plus y. That means find the double derivative, add it with y and get the answer. If one time you know how to differentiate, you all know how to differentiate it 2 times. Not a big deal. dy by dx, phi is a constant, derivative of cos x minus sin x, minus 3 is a constant, derivative of sin x is cos x. Now let's do again differentiation. Second time, dy by dx will become d2y by dx square. Minus 5 is a constant, derivative of sin x is cos x. 3 is a constant, derivative of cos x is minus sin x, that makes it plus. In this d2y by dx square, we want to add y. We want to add y. Why we want to add y? Because it's given. So minus 5 cos x plus 3 sin x plus y is 5 cos x minus 3 sin x. Everything getting cut short. The answer is 0, option E. La 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 la. La 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 la. Alright, so we are towards the end of the lecture. Summarization. Those were the questions from my side. Yes, simpler level of questions. Later on in practice sessions, we'll do much difficult ones. Rolle's theorem condition says, if a function is continuous in closed interval a to b and differentiable in open interval a to b. So continuity in closed interval, differentiability in open interval, and f of a is equal to f of b. Then there is some c in the interval a to b where the derivative of c is 0. That's what your Rolle's theorem says. Now, in order to understand or remember Rolle's theorem, first understand the Lagrange's mean value theorem. LMVT, in short, it is referred as. The first two conditions are same. If it is continuous in closed interval a to b, differentiable in open interval a to b, the third condition is not there. Then there is some c in the interval a to b such that f dash of c is f of b minus f of a upon b minus a. Try to understand this with the help of a diagram. There is a point A, there is a point B. This is your f of A, f of B. Now, if I ask you to tell me the slope of tangent, won't you tell me that it is this is your y2, y1, x1, x2. It is y2 minus y1 upon x2 minus x1. x1 corresponding value y1, x2 corresponding value y2. So y2 minus y1 upon x2 minus x1. So they are just saying if the function is continuous, if the function is differentiable, then there will be some point C in between. There will be some point C in between where if you try to find the slope, it will be given by this formula. And in the same formula now, in LMVT, just put f of b equal to f of a. Put f of b equal to f of a. Will you get 0 when f of b is equal to f of a? When f of b is equal to f of a, you will get 0. That's what your Rolle's theorem is, guys. Remember this Rolle's, 0. Rolle's theorem has a 0. Don't get confused between LMVT and Rolle's. Rolle's theorem has a 0. Oh, and Rolle's theorem is actually from LMVT when you put A equal to B. When you put one more condition in LMVT, you will get Rolle's. The questions generally are verify Rolle's theorem. So if they ask you verify, just you have to verify these three conditions. It's continuous, differentiable, and f of A and B are equal. In A and B will be given to you. If they ask you to verify LMVT, only two conditions you have to verify. If they ask you to find the value of C, then you will properly find the first derivative, put it equal to 0 and you will get C. Find the value of C through LMVT, you will properly solve, put f of B, value of function at B, value of function at A, B minus A. A and B are given to you, function will be given to you. Substitute and you will be able to get C very easily. So this is not there in the CBSE syllabus and not many questions are expected from that topic. Mean value theorems in entrance also. So that was the entire summary of this chapter. I tried to keep it short and sweet. Hope you enjoyed it. Do let me know and let's meet in another session of application of derivative. Thank you so much. Bye bye. That's my time. Take care of yourself. Keep smiling. Love you all, bachcho. Bye.